and my subscribers. Very welcome to the TutorASRumale, the channel dedicated to the tutorials on computer science and engineering, artificial intelligence, software design, advanced technologies and emerging trends. Here I am going to share only the knowledge regarding this and nothing else. I request you all to subscribe my channel, share it with your friends, relatives and contacts which are interested in learning the technologies. Also, I request you to comment and like and suggest me the new topics to cover under this channel. Thank you very much, and welcome you all once again to my channel TutorASRumale. Let's see the today's topic. Thank you.
Uh, we are having here best first search, hill climbing and beam search. But instead I will go like a best first search, beam search and hill climbing, because these beam search and best first search are almost of same category. Or you can say that beam search is the subset of best first search. Okay. Beam search is the subset of best first search. So let me draw a graph for you first, so that we can explain the things. Here you are having these nodes. Okay. Here we are having the node. We are talking about the beam search. Okay. Let's make this a little bit complex. So these nodes are having some connectivities like this. I'm making this a little complex so that we can have connectivity of this, because this will give you the exploratory space or something. And I'm just naming this node here as A, that is our start state. Then we are having this as a B, this as a C, this is your D node. Okay. Here you are having the center node, that is your E node, and then you are having this F, let's call this as a G node. This is your H node. Okay. This is last one, the I node. Okay. And this is also suppose our graph. Just let me change the color of ink now. Now, what happens in best first search? Best first search, we are having two what can say the queues. This is one first queue and this is the second queue. This is the second queue. And we are also having the heuristic function h of n. Now you know that h of n is actually calculated in a way that we call this as a straight line distance from one node to another node. Now let's say this straight line distance, that is from to reach from A to I. Okay, we require some distance like say 10. Okay, we consider that this is not the cost of path. We are considering this is the heuristic distance, that is A to I require 10. Okay, say B to I require say 8. B to C requires say 7. Sorry, C to I requires 7. And so D to I requires 6. Okay, E to I it requires a 5, that is straight line distance. This requires F open cube, and here you are having the closed cube. So we are having here distances, these are the h of n, values of h of n. So for e h of n value is 5, then for here we are having this as a 4, this as a 3, h of n value, this as a 2, okay, and from I to I we can say this is the value 0. Okay, there is no value as a 1 here. Okay, this is our h of n value. So what happened? Let me change the color. Am I audible to everybody? Hello?
Yes, sir, you are
Yeah.
perfectly audible.
Okay. So what happens when we are having this node A in best first search? In best first search. So node, we know that best first search is actually the node which consider all the neighbor or adjacent nodes. So A will see B, C and D, and it will have here these A in a closed list. So A is already in closed list, okay, and it will check the heuristic value of B, C and D to reach to I. So heuristic value of B is 8, C is 7 and D is 6. So it will actually add these things here in open, also in the sorted order, and that sorted order is D, C and B based on the heuristic value of that particular node. Okay, so B is having the heuristic value 8, C is having 7 and D is having 6. So it will consider this D as the next. So D will be added automatically in a closed loop. D will be added in a closed loop. But now just consider that is from this C, which are having the 7 as a this D, 6 is the value to reach to I. Okay, it goes on exploring this D now. So when it go on exploring the D, its expansion is like this. So what we get here, you get these three elements. This is the graph, or this is a tree diagram or traversal diagram for your best first search D. Okay, then you are having this C, and here you are having B. Okay, because D is having the list h of n value. Here h of n value is 10. H of n value is 10 from A to I. It will go from D onwards. So it now D is having what? D is having what? The two nodes to visit. The first node is E. No, E. First node that it can visit is actually H node, and you are having the here E node, because we are saying D is having this H node here, because the value of H node, heuristic value of H node is 2, and then you are having the E node. Then you are having the E node. So it selects the minimal what you can say heuristic value node. So it will select, A will select D, D will from D it will select this H, and so H will be added into the closed loop. H will be added into the closed loop. Now, if from this H, okay, you are having a very big, what you can say, scope. We are not considering those nodes which are actually already explored, because we are coming from D to H, so we are not considering this. So from this H, what you are having, the heuristic value functions. So you are having the two functions here. First is I, that is node, that is a goal state node. Okay, you are having G node here. You are having your 5, that is E node. You already have this E node. Then out of this E, again you are having this C node. I am showing this by things. We, instead of showing the cross links that we have shown in a breadth first search, but you can also consider these as a cross links. So we can go with this something because they are already in the queue. We can say from H we can go to the E node. You can go to the E node. From H you can go to the C node, because those are the values for the thing. But here you are having this I as a 0, and C and E are already in this open, so you are not going to add it. What you are going to add is only the node I. That is what here is. And because I is having the 0 thing, and that is also our goal node, we get this path register. We get this path register. But the thing is that now if I want to explore the other way, I have still the C. Now let's consider that is we got one path that you can go from A to I. One path, that is a one solution from one path from A to I by A, D, H, I. So we can now, let me change the color. Now if you want to go with the new path something, then you may consider not consider this C, and you can go with a C. So the next path will be your C. Okay, next part will be your C. So what are the possibilities in C? In C you are having the possibilities of, in C you are having the possibilities of your H and F. H and F. Again, if you go with this, H is having the path now here to I. H is having path to I, because H is already explored, I is already explored. This path is there, cross-link path, what we call. So what you get, C, H and I. That is an alternative path that we are having. When you go to the Google map, you generally get such type of things. Okay, but what happens from this particular point? If you go on calculating these alternate paths, okay, if you go on calculating the alternate path from this particular point, let's consider this A as a Ahmednagar city. So there are possibly n number of ways to reach from Ahmednagar to Pune. Okay, but out of those n, only 2 or 3 will be optimal. So what this beam search says that let bound the search, best first search, using some beta factor. Let's consider this beta equals to 2. That is, you only need to identify 2 parallel or alternate paths. So your beam will say that you are going to deduct anything which is having higher h of n value, which is having higher h of n value. So what we reduce the scope of A to some beta. This beta is 2. This beta is 2, and this beta factor is called as a beam, and so the best first search is renamed as a beam search algorithm. It's renamed as a beam search algorithm. So it is not different from the best first search. The only thing is that it have this beta, it have this beta factor. Let me